All right. My name is Matt Simons again. I'm excited to be here. You've stumbled into a topic that I care a lot about. So I'm just going to jump into it. The title of the talk is Getting Good at Being Bad, Creating a Culture of Iterative Design. So I'm not going to spend a ton of time talking about me for a couple of reasons. One, because you probably don't care that much about me or who I am, and I applaud your judicious use of cognitive resources. The second is that I'm going to tell you a little bit about me anyways, so we'll get to that. So we'll start with this. These are places that I've lived, anywhere for more than a year. And you probably have two thoughts as you see this map here. The first is something along the lines of like, all right, that's a lot of places, but you're kind of old, so that checks out. And the second is probably something like, what, Russia? And yeah, I lived in Russia for over a year. And then there's probably some small segment of you that are thinking something along the lines of like, Ничего себе, он, наверное, не говорит по-русски. To which I would respond, правда, не говорю по-русски. And then you'd probably say something like, не балуй, ты прямо сейчас говоришь по-русски. And then I'd say, хорошо, но у меня история, которую хочу рассказать. And then you'd say, ну ладно, давай. Now, the point of that exchange is actually to tell you that I speak Russian and to demonstrate it. Not because I want to like pound my chest or brag about it, but because I actually want to talk about linguistics, about learning a language. And specifically, I want to tell you a story about learning Russian. This is a picture of me on the Trans-Siberian Railroad, somewhere between Omsk and Novosibirsk. And then here's one that I'll let you look at that's from, I want to say, Ulan-Ude. In any case, you can look at this one while I tell the story. When I was fairly new to Russia, I was still learning Russian, of course, and I'd say I still have a lot to learn, but I was especially bad at it then. And being new to the country, there was a group of people that I was going to meet. I was, at least part of what I was doing there was learning the culture, learning the language, getting to know the Russian people. And I had an opportunity to stand up in front of a group of them and get to introduce myself. So being fairly new and not really understanding the language real well, I wanted to make a good impression. So I composed a short introduction. And similar to what I said at the beginning of this, I said something along the lines of, I'm really excited to be here, happy to meet all of you, something like that, right? So I composed this short message and I translated it. I pulled out my English-Russian dictionary and translated it, and I was set. I was happy. I was like, this is going to be great. Well, it turns out the word for excited doesn't translate real well into Russian from English. If you're super familiar or have enough exposure to English, you know that the word for excitement is this sort of like, I don't know, aggressive optimism. And surprised that doesn't really have a concept real well in Russian, which is maybe a cultural reflection there in a linguistic artifact form. They just kind of say, we're glad to be here, yarad, they're glad to be there. But if you look in the Russian dictionary, there is a word for excitement, and that's the word I used. So I stood up in front of this group and I said, I'm really excited to be here. And what I got was a mixture of sort of horrified looks and some giggles. And as it turns out, what I learned later was that what I had actually said was something along the lines of, hi, I'm Matt, and I'm really horny to be here. So that wasn't really what I wanted to say. That was a pretty big mistake. They were pretty cool about it, and people talked to me afterwards and let me know the mistake that I had made. But that was something that stuck with me. That was not the first of the mistakes that I made learning Russian along the way, and certainly wasn't the last. But the point is, I want to talk about mistakes. And I made lots of them learning Russian. I still make lots of them. In fact, I probably made a few in that short exchange of Russian that I gave you just a minute ago. Now, there's a number that gets talked a lot about, or at least was talked a lot about when I was learning Russian, and that number is 1 million. And in other words, this is the number of mistakes that it takes to learn Russian if you were an English speaker, or at least this is the story that I was told many times. And it rings true because you have to make mistakes. And if you were to try and learn a language like Russian or any language, and you know, almost everybody on this call is going to know multiple languages. You've been through this exercise. You know that you have to open your mouth. You have to speak it. You can't take something as complex as a language and learn it and then make no mistakes. No matter how many books you read on grammar, no matter how many dictionaries you memorize, you can't perfect something as complex as a language without making mistakes. And that's important. Mistakes are part of the learning process for us. It's how we get to where we eventually want to go in whatever our objective is for what we're trying to do. So there's a really great talk by Dave Renson. And if you don't know who Dave Renson is, he's a former Googler now at Pendo. And I encourage you to look him up and see some of his talks. I'm going to paraphrase probably poorly one of the parts of one of his talks where he talks about sort of the nature of humanity. And something that he says that I think is kind of funny is he says, if aliens were to land on Earth and ask him what humans are all about, he would effectively say that human nature boils down to well-intentioned mistakes. In other words, we have bad judgment sometimes, but we usually mean well. This resonates with me a lot because I think it also talks about how we explore and how we learn, that we have to try things in order to learn and grow. I want to talk about that in the context of a lot of the modern business strategies. So getting to the opening question here, I told you I wouldn't make you wait real long. I think this is one of the common threads that runs through at least most of the really important business and strategies in software. So if we talk about, for example, lean startup, this is going to be horribly reductive, but lean startup, one of the core tenets of lean startup is that effectively, without putting your business in front of customers, you can't actually tell whether what you've sort of set as the core value proposition of your business is validated. You can sit in a closet or in a garage and you can come up with your business and you can have all these ideas about what customers are going to love, but until you actually get them in front of customers, you won't know. There's this sort of principle that like your ideas are probably wrong. Until you talk to customers about them and get your business in front of them, you won't know how it's wrong. You might be 90% right, but that 10% that you're wrong is really important to figure out. Similarly, in Agile, you know, the difference between Agile and Waterfall, this is also horribly reductive and leaving out a ton of nuance, but effectively one of the huge differences is that in Waterfall, we're sort of making this assumption that if we do enough planning ahead of time, if we find every corner case, if we sketch everything out ahead, that we can flawlessly execute on that. And Agile says that's ridiculous, that just going down the path of execution changes the path of execution, and we need to be willing to iterate. In other words, again, we can't just try and plan everything out ahead. Something in our plans are going to be wrong. CI/CD, again, horribly reductive, but this idea that if we fail fast, we can fix fast, that we are inevitably, no matter how many quality gates we put into our code processes, we are inevitably going to break things, and that having long releases is ultimately worse for customers and provides less value than having very short release windows to be continuously integrating and deploying. And while this may seem like a stretch a little bit, chaos honestly is along the same theme, because we're effectively saying one of the core conceits of chaos is that you cannot effectively read the tea leaves and be able to predict every problem that your system will encounter before it goes into production. Again, that any kind of attempting to see all the way through this is a flawed exercise from the beginning, that we are not going to get everything right. So said another way, all of these things have in common this assumption that we are flawed and that we will make mistakes in our process. It says that we are human and we have to account for that. So this leads me to the first assertion. And the first assertion is that good business strategies expect us to be wrong. They make us validate our theories in production, and they take an iterative approach to consistently achieving our best outcomes. Maybe said differently, good business strategies embrace our humanity. They expect us to be human. Let's talk about decisions. This may seem like a bit of a detour. It's not. I promise it's not. And we'll jump into this too. This is a stupid chart. It's stupid because I made it, but hopefully it'll make sense. We'll walk through this. This is all about decision accuracy and effort. So the x-axis here is decision accuracy. How accurate are your decisions? How often are you right? What's your hit rate? The y-axis is the amount of effort that you put into making decisions. Now, you could say this is really subjective, and I'd say you're probably right as we try and graph this out. But I hope that we can agree on a few different points here that will help us at least sketch a rough shape that we can more or less agree on. The first is that there is a threshold for minimum decision accuracy. What I mean by that is if you have two choices, and I mean only two choices, something like the trolley problem. You can't stop the trolley, not choosing is choosing. If you really only have two choices, then your minimum threshold for accuracy is 50%, because over a large enough sample size, you could flip a coin, you could just choose one or the other every time, and you're going to be right about 50% of the time. There's, of course, a lot of nuance, and depending, you probably come up with edge cases where this isn't true, but if we can speak sort of generically here, the number of decisions that we have roughly creates this minimum decision accuracy. And that specifically, in order to hit that minimum decision accuracy, requires zero effort on our part. Again, we can flip a coin, we can just choose something at random if that's the case. All right, the next thing is that there is an asymptote at 100%. What that means is that we can get close to 100%, but we can never get to 100%. No matter how much effort we put in, you can never make a decision right 100% of the time without very definitive evidence, right? And then it's not actually a decision, you're just kind of acting on information that you know is true. So if you actually have to make a judgment call on something, there is no amount of effort that you can put into that if you have to make the decision 1,000,000 times to make it right every single time. And because there's probably people that are pedantic that will watch this, yes, you have to put that same asymptote at 0%, because in order to be wrong all the time, you have to understand what right is. So if we were to poorly sketch this in a way that will make OCD people writhe in their seats, it looks something like this. Again, super rough, but this is kind of how we make decisions, or at least rather the amount of effort that we put into decisions and the amount of accuracy that we get out of those decisions. I'm going to describe one more mechanic here that intersects really importantly, and I'm going to show this as an example. So the common USB stick. Everybody's done this. Everybody's plugged it in the wrong way and then flipped it over, and it's been wrong again, and flipped it over and been right. And it's maddening and infuriating. And there is a way that we could never do this again. If you never want to have to face this conundrum or this frustration again, there's a very simple way to get through this, which is you look. You have to look at the USB, you have to look at the slot, and then you can get it right every time. Again, that makes it not a decision. You're not having to make a judgment call or decide which way you're going to try it first. But you don't care, right? Like, we've done this, we still do this. We know that we can look every time and just plug it in right. But most people, I'll put myself among them, you probably are too, don't care. We try it one way and then we try it the other way. And why do we do that? When we have a method for making this decision correctly every time, why do we still screw it up? And the answer is because we don't care. The consequences are tiny. If we plug it in wrong, if it doesn't go in, we just flip it over and try it again, and maybe flip it over and try it again one more time. And aside from the brief and momentary frustration that causes us, there's really no consequences to having been wrong. And because there's no consequences, we're willing to accept a smaller amount of accuracy in that. So what that means is that we can effectively we can throw another variable in here, that the ease of recovery or the amount of consequences faced on a given decision allows us to define our threshold for accuracy. So in this line is drawn in a different place from the USB example here, but the line for USB would be put all the way at the bottom. We would say that we don't want to put in effort, and we are willing to accept a 50% accuracy rate based on the fact that we give no shits, basically. If that doesn't make sense, I'm going to try and explain it more. what I'm trying to say is that in any sort of important decision, you have two variables that you can manipulate. Where you can manipulate the effort that you put in order to try and get your decision more accurate, but you can also manipulate or you should try to manipulate the consequences or the ease of recovery in those decisions, which allows you to then put less effort into the front side of that equation. Let's go further so that hopefully this makes sense. What I'm saying is if you have a big, scary decision, there are things that you do before the decision, and there are things you can do after the decision. The things you do before the decision increase your decision accuracy. And the things you do after making the decision, the effort that you put into this side of the scale can help you increase your ease of recovery. To bring this to a very specific industry example, let's talk about releasing code to production. Releasing code to production is important. We want to get it right. We don't want to put errors in production. So we have things that we introduce on the left side of this, increasing accuracy, things like code reviews, making small changes so that they're easier to review and easier to catch problems in, testing, so unit testing, integration testing, all other kinds of testing. And we have pre-production staging environments where we can let our code bake for a while and see how it interacts with the rest of the code base and how our emulated users or those sorts of things. All of these things are quality gates that allow us to go to production with a little bit greater certainty and accuracy. But on the other side of things, we have stuff like monitoring and alerting. We have support tooling. We have the idea that small changes are easier to fix forward or roll back. And we have rollback strategies. These are things that we do on the side of ease of recovery. And it takes both of these in order to reduce risk in the system to the greatest degree possible. So the second assertion is this, that the best things we create accept fault tolerance as a primary design constraint, that they attempt to increase recovery in order to reduce reliance on perfect decision making. Because if you remember the first assertion, we're human. We don't make perfect decisions. That's just part of the gig. And to say this another way, good practices, processes, systems, we put effort on both sides of the scale. I want to talk through a case study here. The case study here is important because I want to give sort of a real world example of this, and specifically of how to apply these processes, these principles or assertions within other parts of your company. The premise of this talk, building a culture, creating a culture of iterative design, speaks more to just what we do in code. It is that everything that we do, every process in our businesses and the organizations that we work with or spend our time in can benefit from taking an iterative design to every problem and process that we work through. So I want to talk about specifically the process of creating managers, engineering managers from individual contributors. This may not be super important to you specifically, but I hope it's something that you can at least relate to and understand as we talk through these problems and apply these concepts, either because you are a manager or you have one. I hope that this is something that you can at least follow along with and understand the application of these principles to this specific case study. I want to talk about this as if our processes and our companies are like applications, right? So our HR processes, the way that we move people through the organization, promote people, I want to talk about this as if it's an application. And I want to present to you a specific user story that we're going to create this use case around. And the user story is this. And it's that from the user perspective, I am a relatively new manager. I've learned that I'm not very good at being a manager. And I've learned that maybe because I'm not very good at it, I don't really like it. And I'm thinking to myself, maybe I should go back to being an individual contributor. Maybe I should go back to being an engineer. Now, if you're telling yourself this is kind of an edge case, that tells me you're probably especially lucky and have never worked with anybody either directly reported to or worked alongside a manager that wasn't super good at being a manager. But from my experience, and this isn't supposed to be a reflection on the company that I currently work for, but a statement of all companies that I've ever worked with and worked for, this is pretty common. It's not like the rule, but there are managers that are not great at their jobs everywhere, just like there are engineers that are not great at their jobs everywhere, just like there are humans that kind of suck everywhere. It's a general statement. Rings pretty true to me, probably does to you too. But this is the user story that I want to work through. So a relatively new manager figures out they're not so great at it, maybe they don't like it, and they're looking at maybe going back to an individual contributor. All right. Let's look through, from their perspective, what this looks like. So what are the reasons for them to go back to individual contribution? What are the reasons that they should go back to being an engineer? Looking at personal motivations here. Well, one would be that they have a sense of duty. They recognize that this is the best thing for the company, for them to go back to being an engineer. They're not great at being a manager, they should go back to being an engineer. Another is that they understand that in the long term, going back to being an engineer will probably be better for their career. They were a good engineer, and so they'll probably be a good engineer again, and they'll find progress along that track. Okay, and especially that second one, sometimes in the moment, that's hard to see, but we'll come back to that. The other thing now, reasons not to go back. The first is that it can feel like a demotion. This kind of depends on your culture, but in most, this is a demotion, going back to engineer from engineering manager. And along with that comes all these feelings of shame, fear, the idea that it's an admission of failure. That point alone by itself would be enough to convince most people that like this isn't worth it, right? We mostly make decisions based on our emotions, and that flood of negative emotions around the prospect of going back to being an engineer here would be enough to make most people just go like, nah, not doing it. I'm staying where I am. The idea that you will decrease pay, we're literally going to take money away from you if you go back to being an engineer, is true at most places, not all. Technical atrophy, the idea that if you've been an engineering manager for some amount of time, you maybe code less or maybe don't code at all in those responsibilities, which means that your ability to be an engineer has gotten rusty. To write code, you're rusty. And that would make it embarrassing to go back and kind of be bad at writing code again for a little while. And you'd have awkward relationships with the people potentially that you used to manage. If you've been bad at being a manager, one of the things that you've potentially been bad at is shepherding the careers of the people that you have managed. That your reports maybe haven't been getting the attention to their careers that they've wanted. So there may be some resentment. And now going back and working with them can be difficult to deal with. And lastly, this idea of an identity crisis effectively says that, well, who am I then? If I go back to being an engineer, do I still have a future at this company? Can I still progress? Am I sort of in this admission of failure? Am I cutting myself off from future progression? What can I do? Who am I? That's difficult. Now you may say, Matt, this just means that this person shouldn't be the person who is considering going back to individual contribution and recognizing that they're not real good at it. They shouldn't be the ones making this decision. Their manager should step in. And I'll say, you're probably right. But if we were to build this same list for the manager, if we were to build this, the pros and cons, it's actually pretty much the same list. That they would say, I should send this person back because of a sense of duty and it'll be good for their career. But they were probably involved in making the decision that promoted this person in the first place. So firing or demoting the person that they just fought for to get a promotion reflects on them too, which then brings in an admission of failure, shame, fear, all these things, awkward relationships with them, the idea that, have I broken this person now, this identity crisis thing, right? Like, is this person going to be useless to me? And also the backfill headache of needing to find another person to take that management slot once they vacated. This isn't a simple thing. What I'm trying to paint here is a picture of normal, rational human emotions and thinking applied to a situation that we see all the time. The system itself here has been created in such a way that most commonly our response to how do we do this right is, well, just never promote people that are bad, or never promote people that won't be immediately successful. Let's actually jump into that. Let's actually talk about first kind of our inputs and outputs. If we're examining this as a system, sorry for being out of order here, but if we're examining this as a system, let's talk about our inputs and outputs. What went into the system here? a really great engineer that has leadership potential, probably, right? Except for those edge cases where we deal with something like nepotism or somebody really like gaming the system in a bad way. We've identified these people as really good engineers. They're some of our best and brightest. And the most common outcomes are usually that either they stay as a mediocre manager with a boss that refuses to acknowledge their failures for all those reasons we just outlined on the last slide, or they quit the company because they effectively realize that they are stuck where they're at. They're not going to become move along the management track, but they also feel like they can't go back to individual contribution. And the only way that they can quit that cycle is to go where somebody doesn't know them, to reset the context and start over at another company. Sometimes they get fired if their manager decides to make that decision for them and say, you gotta go. And rarely, but I have seen this, and it's always fantastic when it happens, they can overcome all of those concerns and go back to being an engineer. And it's wonderful when that happens. So now let's get to that question of how do we fix this? And this was a question that I've asked a lot of engineering leaders in different companies. And if we were to treat this kind of like an episode of Family Feud, where we kind of say like, survey says, what's the top answer? Here it is. The top answer that I heard from different engineering leaders all across our industry when I've asked people about this is, they basically say, well, you fix this situation, you have to get really good at promoting exactly the right people. And the secret sauce is, and they tell you what their secret sauce is, that this is how we make sure that we always hire only the right people. Next most common, you see how they do managing interns before you make them a manager. In other words, try something incremental, sort of. This is a better approach, but we're going to talk about how this isn't fully complete. The third is kind of psychotic, which is like you just fire them every time. As soon as somebody shows the slightest hint of being wrong, we just axe them, get them out. And the least most common is you have to let them go back to individual contribution. We have parallel tracks. People do it all the time. The person that I heard this from worked at a company that rhymes with Moogle, and no culture that is sufficiently large is uniform or homogenous across the entire span. But I'll say that they have a reputation there at that company for having a pretty good management culture. This aligns. If these responses were laid before you and you had to choose which company you wanted to work for, I'd choose the last one too. Coming back to this slide, where do these things map? So getting super good at promoting the right people just says we're going to increase our accuracy. We're going to be right 100% of the time. Bullshit, doesn't work. Giving them interns first. This is better. It seems like a more incremental approach, but it's actually just like a pre-production staging environment is all we're saying. This is increasing our accuracy. It's good. It's better than the first one, but it's not complete. The idea that we just terminate awesome engineers doesn't even belong on this list. It should be written in fucking crayon. So I can't write in crayon on a presentation. So it's in Comic Sans. We're going to skip over that. And making it easier for them to go back to individual contribution. That's on this side of the scale. So let's examine this again. I want to tell you what we did, what we are doing. Those are the reasons that people struggle. What we did was we created a new role that is specifically tailored to easing new managers into positions of influence and responsibility, with the ability to roll back as a first order design constraint. What we did was we took all of these things, we considered them challenges, and we created mitigations for them. The idea that it's a demotion or brings about shame or fear or admission of failure, we treated that as a cultural problem. We can mitigate that by making sure that we have an environment where experimentation is celebrated. Like that one answer said, where we have a culture that people go back and forth all the time, you need to be able to create that and say, listen, this person tried to be an engineering manager. They tried it out. It didn't work. But you know what? They tried something and they experimented. This is good. We should celebrate this. They shouldn't be shamed. The decrease in pay is something we can deal with through process by just making a more incremental step. This is back to the slide we'll kind of come back to again, the idea of small changes. The small changes are easier to roll back. Technical atrophy we deal with by specifically dedicating time for individual contribution in this role, which we've also done by, in the next point, by specifically reducing administrative overhead. We're saying that in this role, they are responsible for technical implementation, the technical, so day-to-day workload, managing the work of their peers, of their reports of this group, but they're not responsible for performance and compensation. And so we've taken away some of what they need to do there so that, again, it's easier for them to roll back. They won't have these awkward relationships if they roll back to being an individual contributor. But it also reduces the overhead so that they can take time and we can dedicate time. We literally block it out on their calendars for them to still be individual contributors and keep those technical skills sharp. And on the identity crisis, again, it's a culture thing where we make sure that we set expectations and tell them, like, listen, rolling back is an option. If you end up not liking this or not being good at it, you can go back to an engineer. You still have a place here. We still love you, right? Like that's basically what we're saying. So coming back to this, what this looks like is the team lead position is, you can say that it's kind of like a staging environment again, and you're right, but it's not the only thing we've done. We've embraced small changes. We have a rollback strategy. We've also included other things, like we have frequent formal feedback, which is analogous to monitoring, and we have formal mentorship relationships for them, which is sort of akin to more support. So, and the other things on this list, just to fill it out, paint a picture here, though, what we've done is we've really fleshed out both sides of this from a risk mitigation standpoint. So this user story, what we did to address this, I'm wrapping up here, won't take long, but this is important. What we did to address this is we stopped writing off that user story as bad user behavior. And now we explicitly support individual contributor rollbacks as a valid user path within the application. We embraced our humanity, and we included fault tolerance as a primary design constraint. These are the first two assertions, the first two principles, and we embraced them in this process. And the last thing that I'll leave you with is this. It's that this too is flawed. We're currently running through this process right now with a couple of engineering team leads. So far, it's going great. But like everything else, we're going to retro it. We're constantly evaluating it. We're going to change it. We're going to update it. The thing we have to accept is that we're not always right, that we will make mistakes in everything, even in the important things like this kind of process. But if we embrace our humanity, if we embrace our flawed nature, and we don't try to commit insanely to perfect decision-making all the time, eventually we'll get to a place where we can not make embarrassing mistakes in Russian. So, спасибо вам большое. Thank you very much. I appreciate your time and attention, and I hope this was a good message that you were able to learn something from, that you can take and apply it in the organizations that you work for.